Okay, the basics and the main idea of this internal is to realize that when we take a sample, the median that we get could change if we were to take a second sample. Example, this is height by gender, and this is from the Census at School website, and I've taken a random sample of 30 students from secondary school. I don't think the gender is balanced either. And here you can't make the call that, say, females are taller than males. And if I were to take another sample, you can see quite quickly things flip around. Okay, so that was what you did in year 11. In year 12, this is how your box plot would have looked. Sorry. There seems to have been an error. Gender. Okay, and I'm not sure why there's not a variance bar on this one, but in year 12 there would have been a variance bar, and when the variance bars overlapped, you again weren't able to make the call. Let's see if I can figure out what happens if I just click refresh the data. Anyway, you just have to imagine there's a red line through here, and again you can see that this one is, you can't make the call because any link, well, there will be a red line here that's not showing, but this variance bar actually overlaps with this median, so again you won't be able to make the call here. Okay, and then in year 13 we take it a step further and we do what's called a formal inference, and to do this we use bootstrapping. So you're going to go to Insight, Bootstrap Confidence Interval Construction, Run selected Visual Inference Tool module. Okay, and as per usual we need to input some data. Okay, we'll start where we started yesterday with weight of 9 university students. Okay, and don't forget down here, excuse me while I just move this around. Down here you need to select which variable you want to work with, and in this case it's weight. Then you can go to Analyze, and yesterday we looked at median. I could have equally looked at mean. In fact, let's look at mean today. Record my choices. Okay, from my sample of 9 the mean is 65.89. Now I'm going to resample with replacement these 9 values. Okay, we'll animate it so you can see what's happening. Okay, 270s, 352s, 170, 157, 262s. Okay, and that's the 9 resampled from here with replacement, and we get a new mean. Okay, quite different from the original sample, but what we do then is we repeat that, say 20 times, and I won't animate it this time, and you can see the variance, or how variable the mean that you get from bootstrapping this sample. Okay, the lowest value was about 61, highest value about 72. Okay, and then we can collect a bootstrap distribution of these means by dropping down all these values onto this axis here. Okay, I'll do it once. Okay, so that was that mean dropped down there. I'll do it 5 times. 1 mean, 2 means, 3 means, 4 means, 5 means. Okay, and you can see here we're going to build up a distribution of means. Okay, and 1,000 times. Here we go. Okay, and from these results, we're now going to take a 95% confidence interval to state the range of possible means in the actual population. Show CI. There it is. Okay, so this is normal distribution theory. 100% of the data falls under the bell curve, and when I take 2 standard deviations from the center, either side of the 65.89, I end up with a range. So I would be able to state the true population mean falls between 60 and say 71. Probably would say 72. Round up in that case and down in that case, which gives you a bit more of a buffer. You can click on Bootstrap Distribution Summaries. Gives you the mean. Notice it's not this mean here is not actually this mean here. Okay, 65.9, not 89, and the standard deviation 2.17. Okay, so that's the basics of bootstrapping. In my next video I'm going to show you why bootstrapping works, or an example of why it's around about 95-96% confidence.